How's it going, everybody? Making this video because I posted a picture of this board on the Carvera Air Facebook group, and I mentioned that there's some modifications for this machine that would make it really great at milling PCBs. It's already really good, but what would take it to the level of like an LPKF type machine. A little bit about me real quick. I've been fabricating printed circuit boards for over 2 decades, and a little more than the last decade has been in a small PCB prototyping lab in the audio electronics industry, using all LPKF equipment. All of their different mills from the S62 through the S104, their proto laser U4, yada yada. I don't want to bore you, but anyway, going over some of the things that would make this really good with making printed circuit boards is starting with the dust collection. So I 3D printed this. I modeled and 3D printed this. It allows a little bit of the bit to stick out, and instead of the one that looks like a broom over here brushing along, and which does almost nothing, this one will allow all of the dust to just shoot straight up and out, and it doesn't leave much behind. So that's an easy modification. The other thing, which is a less easy modification, now some of these mods will make this thing miserable at, though I just realized I'm bouncing my camera around, sorry guys. Some of these modifications will make this machine miserable for doing anything other than printed circuit boards. So keep that in mind. I'm only talking about printed circuit boards, nothing else. So anyway, a printed circuit board is never going to be flat. It's always going to have some sort of bow or twist to it. And if you try drilling that with a fine drill bit, the board's going to flex under it and the bit's going to snap, and then you're going to be digging a bit out of the board. So even drilling alignment pins, that's great for your alignment. And you can see how this is all shredded because I taped the board down. That keeps the board from moving, but none of it will make it sit completely flat. So you're always going to run the risk of breaking a bit. So one of the things you would need is a vacuum table. LPKF's machines typically come with a vacuum table except for their lowest end unit, and on that unit I've broken a lot of bits. So yes, that's something I'm working on. I'm working on creating a 3D print for a vacuum table, and it'll hook up to my vacuum system and whatnot. So vacuum table will hold your material flat, it'll hold it in place. You still want to use some tape, but there's that. So using tooling pins for alignment is great. You are going to have a little bit of offset. I've got fantastic alignment doing 4 tooling pins, but a fiducial recognition camera, that's something that every single LPKF machine has. And what it is you'll have a camera up by your head, and it looks down at your board, and there's a offset between where the camera is focused and where the actual tool is. That will allow you to go look at a fiducial or an alignment pin or alignment hole on your board, and it goes and it looks at them, and it will align your Gerber file to what's drilled on the board, if that makes sense. I'm explaining it poorly, but anyway, a fiducial recognition camera, having a camera point down, looking at the board, then you'll be able to actually align your Gerbers to how your board is placed. That way you can remove it from the bed, apply solder mask, you can flip a board over, whatever, and you can do all of your stuff with it perfectly aligned. Last thing, well, not the last thing, there's a lot of things, but one of the main ones, which would really ruin the machine for everything except printed circuit board milling, is a working depth limiter. Basically what has to happen is you have to have this have backlash built into it. So basically what happens is you have a little foot that sticks below your bit, and your bit will stick out the amount that you want it to stick out. It goes over to the material, and the foot hits the material, and you're only cutting as deep as that foot allows, if that makes sense. I'll try and draw it out. But all of LPKF's machines have a working depth limiter, and that would not be great for anything other than PCB milling. But if you imagine, when you have your tiny little V-shaped bit, if you have just the amount sticking out that needs to penetrate the copper layer, this, you don't have to do height mapping on your board at all, because that foot will ride along and you're only going to cut as deep as you have the bit set within the foot. All right, so that's about 5 minutes of me rambling and shaking the camera around and being nuts, but that should give you guys an idea of what I was talking about when I was saying that I've got suggestions for how to make this machine compete with an LPKF machine, and it's not a long shot. Oh, another thing would be having them build into the software a scratch test with a live tool offset. And what I mean by that is after you've probed your surface, you've done your height map of your surface, you can do a scratch test, meaning you bring your bit over to your material and you go down the amount that your G-code file says, and it just does a little scratch one way, scratch the other way. Then you can look at that scratch and you can see if it's cutting at the width that it should be cutting for that depth. If not, you can then do a offset in the software to either bring the tool offset up or down, so then you don't have to use a working depth limiter on the machine. You could just do a live offset after doing a series of scratch tests to make sure that it's cutting the width that it should be. For example, like if you go into flat cam and you say you have a V-shaped bit and it needs to pierce 50 microns into the material, then you get over to the material and you're piercing the 50 microns and it's barely breaking the surface because it's a different copper weight, or it's going too deep and cutting too wide. You have to adjust that, and then you have to go back to your cam software, back into flat cam, readjust. They should be able to allow you to do a tool offset, because you're already measuring the tool length with this little button here. Why can't you, in the controller software, do a scratch test somewhere on, not where your circuit is or whatever your cutting is, and take a look at it, measure it. If you had a fiducial camera, you could bring the camera over it and measure it on screen. But anyway, enough rambling. Sorry, guys. I will actually do a professional video at some point, or, well, not professional because I suck at making videos, but I will do a better video at some other point, and I'll do a video showing my process of how I got to this, because a lot of people commented on solder mask and whatnot and how it looks really smooth, and I've been doing this a really long time, 25 years-ish now, so I've got some practice. But this was actually really easy. I did this board over the course of, 2.5 hours total, and that was from design to being finished. So, all right, have a good day.